So we're going to look at last night's homework, 6-3 and 6-4 study guide and intervention worksheets. Those are over solving systems of linear equations using the elimination method. The front side is over adding or combining. The back side is over subtracting, where you have to distribute a -3 to cancel one of those variables out. And the last side is over multiplication, so you have to multiply through by a number, at least one of them, to change them in order to cancel one of the things out. So I'm going to work through those with you today, and then you're going to have another worksheet that you can work on your own so you get a little extra practice. So you should have last night's homework out on your desk. Starting with number 1 on the front, we have x plus y is equal to -4, and x minus y is equal to 2. I can just combine these together because the y's will cancel out. Since one's a positive and one's a negative, the y's will cancel out. So combining together, I have an x and an x, so that gives me 2x. Positive y minus y goes away, so is equal to -4 minus 2, or -4 plus 2 gives me a -2. Okay, so I'm going to divide both sides by 2. X is equal to -2 divided by a +2 is a -1. When I get -1, I can plug that back into either one of these equations. I'm going to go ahead and plug it in right here and say that -1 plus y is equal to -4. I would add a 1 to both sides to get y by itself. So y is equal to -3. When I write my answer, I want to write it as an ordered pair, keeping x first, y second. So my ordered pair is -1, -3, and that's my final answer for number 1. Moving over here, we're going to go ahead and work out number 2. I have 2x minus 3y is equal to 14. And x plus 3y is equal to -11. Looking here, I have a 2x and an x. I have a -3y and a plus 3y, so those two are going to go ahead and cancel each other out. So all I have to do is combine. I have a 14 and a -11. So just starting from top to bottom, 2x plus another x is 3x. -3y plus 3y cancels out, is equal to 14 minus 11 is 3. 3x equals 3, so I'm going to divide both sides by 3. X is then equal to 3 divided by 3 is 1. I can choose either one of these to plug that back into. I'm going to go ahead and plug it in right here. Since the one's by itself, it just saves me one more step. 1 plus 3y is equal to -11. I'm going to subtract a 1 from both sides and get 3y is equal to -11 minus 1 is a -12. So I'm going to divide both sides by 3. And I get y is equal to -12 divided by 3 is a -4. And so when I combine those two together to make my ordered pair, x and then y, my answer for number 2 is 1, -4. Okay. Moving right along with number 3. Number 3 says 3x minus y equals a -9. And -3x minus 2y is equal to 0. I have a positive 3x on top of a -3x, so they're going to cancel each other out. So I have -y minus 2y is a -3y is equal to -9, and 0 is just -9. -3y means -3 times y, so to undo that, I'm going to divide. Do it to one side, do it to the other. Y is equal to -9 divided by -3. A negative divided by negative is a positive, so y is equal to 3. Go back in and plug that into either one of these. I'm going to go ahead and plug it into the first one and say 3x minus, and in place of y, I'm putting in a 3, is equal to -9. Solving for x, I'm going to add a 3 to both sides. 3x is equal to -6, divide both sides by 3, and I get x is equal to -2. So when I combine those two together for my ordered pair, x is negative 2, y is 3. So my answer is negative 2, 3. Taking a look at number 4, once again I have a negative 3x over a positive 3x, so when I combine those together, they'll go away. So then I have a negative 4y and a negative y, which together gives me negative 5y. Negative 1 and negative 4 together give me a negative 5. So when I divide both of these sides by negative 5, y is equal to a positive 1. Negative over a negative is a positive. I can plug that into either one of these. I'm going to go ahead and plug it in here because y is already by itself. Makes it a little bit easier. So this 1 goes right here in place of the y. So to solve for x, I'm going to add a 1 to both sides, leaving me with 3x is equal to negative 3. Divide both sides by 3, and x is equal to negative 1. Combining those together to make an ordered pair, make sure you put your x first and then your y. So your final answer for number 4 should be negative 1, 1. Make sure you have all of this work shown, or else you will not get credit for these problems. Number 5. (3x plus y) equals 4. 2x minus y equals 6. I have a 3x and a 2x, but I have a plus y and a minus y, so they're going to cancel each other out. So 3x and 2x is 5x. The y's canceled each other out. A 4 and a 6 gives me 10. So I'm going to divide both sides by negative 5, and x is equal to 2. Go back and plug that in. I'm just going to go ahead and plug it into the top one. 3 times 2 plus y equals 4. 3 times 2 is 6. So 6 plus y is equal to 4. I'm going to subtract this 6 from both sides, and I get y is equal to negative 2. So for number 5, when I combine my x and y together to give me an ordered pair, I have the point 2, negative 2. Negative 2x plus 2y is equal to 9, and 2x minus y is equal to negative 6. Once again, I already have it set up for me that they'll cancel each other out. So just my x's cancel out, having a negative 2x and a positive 2x. And then I have a positive 2y minus y, leaving me with 1y. And then 9 minus 6 is 3. So y is equal to 3. I can then go back and plug that into either one. I'm going to go ahead and plug it into this one right here. And so that gives me a 2x minus 3 is equal to negative 6. I'm going to add a 3 to both sides and get 2x is equal to negative 3. Divide both sides by 2. And I get x is equal to negative 3 over 2. It is perfectly fine to have a fraction in there. That just means that your two lines would cross at a fraction spot. No big deal. So when I go to write my ordered pair, I have negative 3 over 2, 3, making sure I keep my x value first, my y value second. Okay? 7, 8, and 8 are both word problems, so let's go ahead and take a look at those. Here you have to build your system of equations first. So it says Remy is older than Ken. The difference of their ages is 12, and the sum of their ages is 50. Find the age of each. So let's kind of go back and look at that. I know there's two people, Rema and Ken. Rema is older than Ken. That will be more important at the end for me to determine which is which. You're welcome to use R and K if that helps you, but I'm just going to go ahead and use X and Y. The difference of their age is 12, so that means if you subtract the two numbers, you get 12. So the first equation in my system is X minus Y equals 12. The next part says the sum of their ages is 50, which means X plus Y is 50. Sum means to add. Okay. I have an X and an X, but I have a negative Y and a positive Y, so those two are going to cancel each other out. X and X is 2X is equal to 12 and 50 is 62. Divide both numbers by 2. X is equal to 31. You can plug that into either one of these. I'm going to go ahead and plug it in here and say 31 plus Y equals 50. The reason I chose this one is because the Y is already positive, so it saves me a step. If I were to plug it in here, I would have a negative Y left over, and so I'd have to divide by -1. You're still going to get the same answer, just adds an extra step in. The more you work with this, the more you'll see like ways that you can take a step that takes out extra steps. So I'm going to subtract the 31 from both sides, and Y is equal to 19. Now, they don't want an ordered pair. They want to know each of their ages. So Rema, it told us, was the older, so she is 31, and Ken is 19. Moving on to number 8. Number 8 says the sum of the digits of a two-digit number is 12. So we have a two-digit number, like put together, like 54 or 38 or 62, a two-digit number. The difference of their digits is 2. So X minus Y equals, 12. No, I lied to you. Let's look back at our problem. The sum of the two digits is 12. So that means X plus Y equals 12. And then the difference of their digits is 2. So that means X minus Y equals 2. The last part says, find the number of the unit digit is larger than the tens digit. So that will help us at the end. So let's go ahead and solve this here. X and X is 2X plus Y minus Y cancel each other out. 12 and 2 is 14. So I'm going to divide both sides by 2 and get X is equal to 7. Go back and plug that in. I'm going to go ahead and plug it into the first one and say 7 plus Y equals 12. So I'm going to subtract the 7 from both sides and get Y is equal to 5. So the two digits of the number are either 7 or 5. Now we just have to figure out if it's 57 or 75. And so since it says the sum of the digits of a two-digit number is 12, so 7 plus 5 is 12, yes. The difference of those is 2. 7 minus 5 is 2, yes. And then it says, find the number if the units digit is larger than the tens digit. So when you have a two-digit number, this is your tens and this is your units. Okay? Well, it told me that the units digit is larger. So since 7 is larger than 5, it's going to go here. So my answer is 57. So you just kind of have to like piece that puzzle together after you solve. Okay? Moving on to the next page. The next page is where we're using subtraction. So you're going to have the same numbers on top of each other, but they're both going to be positive or they're both going to be negative. So you need to distribute a negative through to one of them. I usually choose the bottom one. There's two ways that you can do it. You can distribute it through and just rewrite it across the top, or you can rewrite the problem altogether. When you first start out, I kind of suggest rewriting the problem altogether so that way you don't get confused. So I'm going to kind of flip back and forth and do it both ways. Alright, so turning the page over, working number 1 on the back side of the first page, it says 6x plus 5y is equal to 4. And then it says 6x minus 7y is equal to negative 20. Okay. Just double check my paper, make sure I've got that copied down right. 6x plus 5y equals 4. 6x minus 7y equals negative 20. Alright, so I have a 6x and a 6x on top of each other, but I need them to be able to cancel out, and right now those combine together to give me 12. So I just want to make this one a negative. But if I make this one a negative, I have to distribute that negative all the way through this equation. So I'm going to distribute out a negative, making this a negative 6, which turns this into a positive 7, which turns this into a positive 20. So if you want to do it like that, where you just mark through, that's fine. However, a lot of you just starting out may want to rewrite it and say 6x plus 5y equals 4. And then negative 6x plus 7y equals 20. It may make it a little bit easier so you don't have all this extra mumbo jumbo down there. Okay? Either way, 6x minus 6x goes away. 5y plus 7y is 12y. And 4 and 20 give me 24. So after I distributed that negative through and changed the sign of everything, it just becomes a problem like we just got through doing. So I'm going to divide both sides by 12 and get y is equal to 2. Go back and plug that into one of your original problems. Make sure that you don't plug it in over here because sometimes that'll give you an error. So I'm going to go ahead and just plug it into my first one and say 6x plus 5y, and in place of y I'm putting a 2, is equal to 4. 6x plus 10 equals 4. Subtract the 10 from both sides. 6x is equal to negative 6. Divide both sides by 6. X is equal to negative 1. So when I combine that together to write my ordered pair, I have a negative 1 and a 2. So I'm going to say negative 1, 2 for my final answer. On number 2, I have 3m minus 4n is equal to negative 14. And then I have 3m plus 2n is equal to negative 2. We double check, make sure that that's exactly what mine looks like. 3m minus 4n equals negative 14, and 3m plus 2n is equal to negative 2. Alright, so once again, I have two 3m's on top of each other. So I'm just going to distribute through a negative to cancel this out. I know that you already know multiplication process as well, so another option to work this one out would be to multiply this whole thing through by a 2, because I have a negative 4 and a positive 2, and if I multiply everything by 2, it would cancel the ends out. Both of those will get you the same answer, but I'm going to go ahead and, since these have the same number, just go ahead and change the sign for all of these. So if I were to distribute a negative sign through, this would become a minus, this would become a minus, and this would become a plus. So 3m minus 3m goes away. 4 minus 2n, negative 4 minus 2n becomes a negative 6n is equal to negative 14 plus a 2 becomes a negative 12. Divide both sides by negative 6, and n is equal to 2. Go back in and plug that into one of your original problems. I'm going to plug it into this one right here. And so I'm going to say 3m minus 4 times 2 is equal to negative 14. 3m minus 8 equals negative 14. I'm going to add an 8 to both sides. And I get 3m is equal to negative 6. Divide both sides by 3, and m is equal to negative 2. Now, in your alphabets, A, B, C, D, E, F, G, going all the way through, when you get to m and n, it goes L, M, N. So when you list your coordinates, you need to keep them in alphabetical order. So your m goes before your n, just like your x goes before your y. So when I list this as an ordered pair, I need to make sure that my negative 2 comes first, because in the alphabet, m comes before n. Okay? Number number 3 says 3a plus b equals 1, and then a plus b equals 3. Double check and make sure that's right. 3a plus b is equal to 1. A plus b is equal to 3. I'm going to go ahead and distribute a negative through here to make this b cancel out with this b. So this becomes a negative a minus b and a minus 3. Okay. 3a minus a becomes a 2a. B minus b cancels out, and 1 minus 3 becomes a negative 2. Divide both of those sides by 2, and a is equal to negative 1. I'm going to go ahead and plug that back into this original problem. Now remember, that original problem was just a plus b equals 3. Make sure you plug it back into the original. So negative 1 plus b is equal to 3. I'm going to add a 1 to both sides and get b is equal to 4. So once again, alphabetically, a comes before b. So when I write that as an ordered pair, a, b. So negative 1, 4. Number 4 says negative 3x minus 4y is equal to negative 23. And then I have negative 3x plus y is equal to 2. So once again, I have the 3x on top of the 3x. That could cancel each other out, however, they're both negative, so that would make a negative 6x. So I want to turn this one into a positive. So I'm going to do that by distributing a negative all the way through. So this negative becomes a positive, this positive becomes a negative, and this one becomes a negative. You're more than welcome to just kind of scribble out your answer and write it on top, or if you want to rewrite your problem, I do suggest that you may do that. For the sake of time for the video, I'm just going to go ahead and work them out and combine them this way. So I have negative 3x plus 3x, which goes away. Negative 4y minus y is negative 5y, is equal to negative 23 minus 2 is a negative 25. Divide both sides by negative 5, and y is equal to a positive 5. I'm going to go ahead and plug that in here to my original problem. So I have negative 3x minus 4 times 5 is equal to negative 23. Negative 3x minus 20 equals negative 23. Add a 20 to both sides. Negative 3x is equal to negative 3. When I divide both sides by negative 3, I'm left with x is 1. So when I write that as an ordered pair, I have 1, comma 5. Number 5. Once again, my y's are matched up. It's just both of them are negative. So I'm going to go ahead and distribute a negative through here at the bottom. That makes this a negative 2. That makes this a positive 3. And that makes this a negative 16. So x minus 2x is a negative 3x. The y's cancel out. And 11 minus 16 gives me a negative 5. I'm sorry, I am wrong here. That's a positive x minus 2y. So x minus 2y gives me a negative x. So if negative x is equal to negative 5, that means positive x is equal to a positive 5, and I can get that by dividing both sides by negative 1. So recap real quick. X minus 2x was a negative x, not a negative 3x. And since negative x equals negative 5, positive x equals positive 5, because I just divided through by negative 1. When I go back in and plug that in, I get 5 minus 3y equals 11. Subtract a 5 from both sides and get negative 3y is equal to 6. Divide both sides by negative 3, and y is equal to negative 2. So when I combine my 5 and my negative 2 to make an ordered pair, I have the pair 5, negative 2. Number 6 is x minus 2y is equal to 6, and x plus y is equal to 3. Once again, I have x's on top of each other, but they're both the same sign, so I'm going to distribute a negative through. That makes this a negative, that makes this a negative, and that makes this a negative, because they were all positive to begin with. X minus x goes away. Negative 2y minus y becomes a negative 3y. 6 minus 3 becomes a positive 3, so I divide both sides by a negative 3 and get y is equal to negative 1. When I go back in and plug that in, I'm just going to plug it in right here. So I'm going to say x minus 2 times a negative 1 equals 6. Negative 2 times a negative 1 is a positive 2. So this becomes x plus 2 equals 6. Subtracted 2 from both sides. And x is equal to 4. So when I combine those together to give me an ordered pair, I have 4, negative 1. Alright, 7 and 8, once again, are word problems. So we need to be able to build our systems of equation. There's an extra step added in here because if you remember or if you've noticed, all my equations are set up the same in the same form, like a standard form where we have x and then y is equal to the number. When we set some of these up, they won't always set up like that. So if they're not set up the same way, then you have to do a little bit of algebra to move it into that. And so that looks like number 7. Number 7 says, the sum of two numbers is 70. One number is 10 more than twice the other number. Find the numbers. So the first equation is the sum of the two numbers is 70. So that's pretty easy. The sum means we're adding, so x plus y is equal to 70. The second one says one number is 10 more than twice the other number. So we're just going to write that exactly as it looks. One number, and it doesn't matter which one you pick, so I'm going to say x. So let's say x is, which is equal to, 10 more than means it goes at the end because you have something, and then you're going to add 10 to it. So twice the other number was y, twice that would be 2y, and then we're adding the 10 to the end. Remember, that's like the Sailor thing. How can I have some more of something if I haven't had something to begin with? So we twice the number and then add 10 to it. Okay? So once again, I have x and y on this side, but I have x over here and y over here. So I'm going to subtract the 2y to move it over here, because if I do it to one side, I do it to the other. And this equation becomes x minus 2y is equal to 10. So now I'm going to use this equation and this equation to create a systems of equations. So I have x plus y equals 70, and I have x minus 2y is equal to 10. You can do one of two things here. You could have multiplied this through by 2 to cancel those out, or you can just distribute a negative through here. Right now I'm just going to distribute a negative through because on this lesson you haven't learned multiplication yet. So we're just going to go ahead and do it the way that this problem works out, but I just want you to know that both ways will give you the right answer. So I'm going to distribute a negative through here, so those x's will cancel out. So this becomes a negative x, this becomes a positive 2y, and this becomes a negative 10. Okay? X minus x goes away. Y plus 2y becomes a 3y, and 70 minus 10 is 60. So if I divide both sides by 3, then y is equal to 20. When I go back and plug that in, I'm going to plug it in right here and say x plus 20 equals 70. When I subtract the 70 from both sides, or 20 from both sides, I get x is equal to 50. So my two numbers are 20 and 50. Now let's go back into our word problem and make sure that makes sense. It says the sum of the two numbers is 70. 20 plus 50 is 70. One number is 10 more than twice the other number. Well, if I twice 20, 20 times 2 is 40. If I added 10 to that, I would get 50. So it does work out. Okay. So number 7, we're going to do the same way. We have to build it first. It says two angles are supplementary. Supplementary means they add together to give me 180. The measure of one angle is 10 more than 3 times the other. So it's the same kind of setup. We're just using a little bit different numbers. So if together they're supplementary, they add together to give me 180. So x plus y is equal to 180. And then if one number is the measure of one angle, so angle x, is 10 more than, so I'm going to add 10 to 3 times the other number. Once again, I'm going to get those to be set up where the x and the y are on the same side. So this becomes x minus 3y is equal to 10. So I'm going to use this one and this one to create my system. So I have x plus y equals 80, or I'm sorry, 180. And I have x minus 3y is equal to 10. I'm going to distribute a negative through here so my x's cancel out. So this becomes negative x, this becomes a positive 3, and this becomes a negative 10. So x minus x goes away. Y plus 3y becomes 4y. And 180 minus 10 becomes 170. When I divide both sides by 4, it doesn't work out evenly, but it gives me a decimal, and that's fine. Okay, so this is 42 and a half. Y is equal to 42.5. When I plug that back in, I see that x plus the 42.5 should equal 180. If I subtract a 42.5 from both sides, I get that x is equal to 137.5. So I have an obtuse angle of 137.5 degrees, and I have an acute angle of 42.5 degrees. Together they're supplementary. I can add them together to get 180. And then if I multiply this times 3 and added 10 to it, I would get this number right here. You can always double check that at the end to make sure that your rules still stand true when you solve the equation. All right, so moving on to the last page is multiplication. It's when you can't just automatically change the sign of something or just combine them together. So you've got to kind of do a little more thinking. So number 1 says 2x plus 3y equals 6, and x plus 2y equals 5. Well, since this x is by itself, I could easily turn it into a negative 2x to cancel out here to get rid of it. I need it to be negative because this one's positive. I need a 2 in front of here. So I just say, hey, I need a negative 2 to cancel those x's out. Once I decide what I want to do, I have to distribute it all the way through. So this stays the same as 2x plus 3y equals 6. And this is going to be negative 2 times x is negative 2x. Negative 2 times 2y is a negative 4y. And negative 2 times 5 is a negative 10. So once I distribute that out, I have my new problem. I'm going to go ahead and combine those together. Those go away. Negative y is equal to negative 4. So that means positive y is equal to positive 4. I get that by just dividing by negative 1 on both sides. Take that and plug that back in. I'm going to plug it into this bottom one right here, so x is by itself. Doesn't matter. You can plug it into the other. You're still going to solve and get the same answer. X plus 8 equals 5. Subtracting an 8 from both sides, x is equal to negative 3. So when I write that as an ordered pair, I have negative 3, 4. Moving on to number 2. Number 2 is 2m plus 3n equals 4. And negative m plus 2n equals 5. I already have a positive over a negative right here. This m is by itself, so all I need is a 2. So to me, the easiest way to do this is to multiply the whole bottom through by 2. So when I do that, my new problem becomes 2m plus 3n equals 4. And this becomes negative 2m, and then 2 times 2n is plus 4n is equal to 2 times 5 is 10. Make sure you distribute it all the way through. If you do it to one part, you have to do it to all the parts.
Teachers, please post attendance. Again, teachers, please post attendance. Thank you.
All right, so 2m minus 2m goes away. 3n and 4n gives me 7n. 4 and 10 gives me 14. So then I'm just dividing by 7, and n is equal to 2. I can go back and plug that into either one of my original problems. So I'm going to go ahead and plug it into the first one and say that 2m plus 3 times 2 is equal to 4. So 2m plus 6 equals 4 minus 6 minus 6. 2m is equal to negative 2. Divided by 2, divided by 2. M is equal to negative 1. A, B, C, D, E, F, G, blah, 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 blah. L, M, N. So in order, alphabetically, my ordered pair goes negative 1, 2. Number 3 says 3a minus b equals 2 and a plus 2b equals 3. I have an a by itself and I have a b by itself. So you can choose either one of them to get rid of. I'm personally going to go ahead and get rid of this b. Since this one's positive and this one's negative, all I have to do is multiply by through by a 2. So I don't have to worry about any signs. But if you would have done it the other way, you're still going to get the same answer. It's okay. So when I multiply the whole top through by 2, 2 times 3a is 6a. 2 times negative b is negative 2b, equal to 2 times 2 is 4. And then my bottom equation just stays the same as a plus 2b equals 3. 6a and a becomes 7a. The b's canceled out like I wanted them to. 4 and 3 become 7, so when I divide both sides by 7, a is equal to 1. I'm going to go ahead and plug that in right here and say 1 plus 2b is equal to 3. Subtract the 1 from both sides. 2b is equal to 2. Divide both sides by 2, and b is equal to 1. So alphabetically, a comes first, then b, but it really doesn't matter since they're the same number. But this is the a value, this is the b value. Okay, number 4. Number 4 is a little bit different because you can't automatically just get rid of 1. I have 4x plus 5y equals 6, and I have 6x minus 7y equals negative 20. So I don't have anything that I can just multiply on to something. I can't multiply 4 by something to get 6, or 5 by something to get 7. So I'm going to have to multiply both of them through. You can multiply this by a 6 and this by a negative 4 to cancel those out. You can multiply this through by a 7 and this through by a 5 to cancel it out. Your options are endless. I try to get smaller numbers. So looking at 4 and 6, I know I can get to 12 by both of those. 4 times 3 is 12 and 6 times 2 is 12. So I'm going to go ahead and multiply by those two numbers to keep my numbers that I use smaller. You can use other things. It'll just be bigger numbers that you have to deal with. Now, since I want to get rid of the x's, they're both positive. So I'm going to multiply my top through by a positive 3 to get to 12. But I'm going to multiply my bottom through by a negative 2 to make that a negative 12. So I have a positive 12 and a negative 12. So once I decided to get to 12, 4 times 3 gets me 12. 6 times 2 gets me 12, but I need it to be negative. So I'm going to multiply through by a negative 2. Okay? So my new problem becomes 3 times 4 is 12x. 3 times 5 is 15y. And then 3 times 6 is 18. Negative 2 times 6 is negative 12. Negative 2 times 7, or a negative 7, becomes a positive 14. And then negative 2 times negative 20 becomes a positive 40. So that becomes my new sets of numbers to deal with. So I'm still dealing with some pretty big numbers, but it would have been even bigger if I would have chose other ones, which is fine. You're still going to get the same answer. 12 cancels out. So that leaves me with 29y is equal to 58. Would I combine those together? If I divide both sides by 29, y is equal to 2. I'm going to go back and plug that into either one of my original equations. I'm just going to throw it into the top one where it said 4x plus 5y, so 5 times 2 is equal to 6. 4x plus 10 equals 6. Subtract the 10 from both sides. 4x equals negative 4. Divide both sides by 4. X is equal to negative 1. So my ordered pair is negative 1, 2. Don't forget, you can always go back and plug those in. 4 times negative 1 plus 5 times 2 equals 6. Yes. 6 times negative 1 minus 7 times 2 is negative 20. Yes. So you can always plug it back in to make sure that your answer is right. Alright, I have a 4 and a 2 here. There's a couple different things I could do. I can multiply this through by a negative 2 to cancel out my x's, or I can multiply this through by a 3 to cancel out my y's. I'm going to go ahead and just multiply through by a negative 2 and get rid of the x's, but you could have multiplied through by a 3, but you would have added a negative 3 to make it positive. So I'm just going to go ahead and say negative 2. So that becomes my new problem. Let me go ahead and erase this over here also. My new problem, but 4x minus 3y stays the same. And then negative 2 times 2x becomes negative 4x. Negative 2 times negative y becomes a positive 2y. And then negative 2 times 10 becomes a negative 20. Okay? So, as I go through here, my x's cancel out. Negative 3y plus 2y becomes a negative y is equal to 22 minus 20 is a positive 2. But negative y equals positive 2, so that means positive y equals negative 2. I can get that just by dividing by negative 1. But if I change the sign of this one, I would change the sign of that one. Go back and plug that back in. I'm going to plug it in right here and say 2x minus a negative 2 is equal to 10. So that's like 2x plus 2 equals 10. Subtract the 2 from both sides. 2x equals 8. Divide both sides by 2. X is equal to 4. So if x is 4 and y is negative 2, my ordered pair becomes 4, negative 2. And then lastly, number 6. 3x minus 4y equals negative 4. And then x plus 3y equals negative 10. I'm going to go ahead and just multiply this through by a negative 3 to make that a negative 3 to cancel out. So I have 3x minus 4y is equal to negative 4. And then I have negative 3x. Negative 3 times a positive 3 is a negative 9y. Negative 3 times a negative 10 is a positive 30. Positive 3x, negative 3x cancel out. Negative 4y and negative 9y give me a negative 13y is equal to 30 minus 4 is 26. Divide both sides by negative 13. And y is equal to a negative 2. When I go back and plug that in, I'm going to plug it into the second equation just because it makes it a little bit easier. So you can plug it in anywhere you'd like. I'm going to say x plus 3 times negative 2 is negative 10, which makes x minus 6 equal negative 10. Add a 6 to both sides. X is equal to negative 4. When I go ahead and combine those together, my ordered pair is negative 4, negative 2. Miss Felicia has a worked out example of this over there with her. So if you missed one or you need to see another one or you need to see it a little bit longer, go ask her for that key. She can let you see it. Other than that, you have another worksheet to do this. You need to do it on your own. This is due tomorrow.